So volume, formula for volume of a cylinder is V equals capital B times H. And it does matter that you use a capital B versus a lowercase b. It's a V for volume. So this is what the V, the capital B, and the H stand for. We have volume. The reason it's a capital B is because it's not just talking about the base of something, it's talking about the area of the base. And then we have the height of the cylinder. Who can tell me what shape would be considered the base of a cylinder? A circle. So the capital B here stands for area of a circle, which is pi r squared. Because our base is a circle, we would take this little section here and substitute it in for capital B. And we're going to practice that over and over, so you'll get the hang of it. So we know that to find the volume of a cylinder, we do capital B times H, which is the same as pi r squared times H. What's the R stand for?
Radius.
And what is the radius of a circle? Half of what?
The diameter.
Half of the diameter, which is the distance across, right?
Circumference.
That's the distance around, is the circumference. Right? Okay, so we have two examples we're going to do here for cylinders. First thing I'm going to do is draw the cylinder. So the way I draw a cylinder is to kind of make like an oval shape, which seems strange, but it's three-dimensional. And then I do little dashed lines to show the third dimension there. Okay, so I need the height of the cylinder and I need the radius of the cylinder. The radius for this one is going to be 3 centimeters.
We're going to have to draw all this.
Most of the things you'll be given, but for our notes I can't actually do that. I know this is just the radius because, as you can see, it looks like it's supposed to go halfway across. And then the height, I'm just giving random numbers. It's not proportional. The height is 6 centimeters. Okay, so let's go ahead and use the formula. We're going to solve this two ways. We're going to solve it approximate value and exact value, right? So it's not super unlike what we did at the end of Pythagorean theorem where we found exact values. So we're going to write approximate and exact. So then for approximate, I'm going to start with volume equals area of base times height. Volume equals pi r squared times the height. Now I'm going to put the values in. We're going to use 3.14 for pi. My radius is 3, so 3 squared, and my height is 6.
That's 3 squared or 3 to the first power?
3 squared. So then I would have volume equals 3.14 times 9 times 6. And then my answer, because it's an approximate, is going to have the little squiggle marks. Because remember, 3.14 is just an estimate of pi. And when I multiply 3.14 times 9 times 6, I get 169.56 centimeters. And then how do we label volume? With a cube. Yep. Because it's 3 dimensions. So we label it with 3.
Is this the last that's going to be on the page? Because, like, the exact.
We're going to do exact, and then I'm going to do another example at the bottom. Yep. Okay, so exact is not terribly different. Down by the LGI. That's why I don't teach 7th grade. Okay, my next line is going to look the same as well. Pi r squared h. And this is where it gets different than the ridge that we did before. I'm not going to put 3.14. I'm just going to keep the pi symbol there. Pi times 3 squared times h. Or excuse me, times 6. I'm just going to continue to leave that symbol there because once I actually do the math with that symbol, it's no longer exact because pi is an irrational number. So then I'm going to have volume equals pi times 9 times 6. Maggie, do you have a question?
Nope, I was like, no, I don't.
Okay. And then my answer, because it's exact, I'm going to do 9 times 6, and I'm going to get 54. And then I'm going to put the pi after it, centimeters cubed. So I have my approximate value and my exact value. This is also known as in terms of pi. So if you saw somewhere that said leave your answer in terms of pi, that means you leave pi as part of the answer. You do not use the value of it. How do we feel about volume of cylinders?
Awesome.
Okay, let's do another one. It is not. What is that 8 feet? It's the diameter. So if I'm given the diameter of 8, somebody just said it, how do I find the radius? Divide it by 2. Because if all the way across is 8, then halfway across would be 4. So you guys are going to go ahead and find the approximate and the exact value. There, I did the first 2 steps for you on both of them. You're welcome. I like to try to help when I can. You're going to have to get out your calculators to do these. guys ready? Jackson, you get all this written down?
Yeah.
602.88 feet cubed. That's our approximate value. Our exact is 192 pi feet cubed.
What? I got those both right. Oh, did you?
Okay, so if you made a mistake, where did it happen? Which step?
Well, I don't know what that because I did 3.14 times 16 times 12.
Uh-huh.
And I got 954.
Try it again in your calculator, because maybe you just pushed a wrong number. Instead of 16, maybe you did 19 or something. I don't know.
2,411.52. Yeah, so did I.
Did you guys use 4 squared or did you use 8 squared?
8.
So it should be 4 because the radius is 4. You were given the diameter. Mia, did you?
I multiplied it wrong.
Okay.
So you divide the 8 by 2.
Yep.
Like you got a diameter by 2.
Yep. Yes,
I
Carmen.
would like to say something.
Okay.
So, Hannah got it wrong, and I asked her, because she had 28 as the answer for 16 times 12. And I was like, Hannah, what is 16 times 12? And she answered very confidently 28.
Okay. That's fair, but it maybe should have been like a, hey, this doesn't seem big enough. This value doesn't seem like I did this right. Okay, how did we do on the exact values?
Awesome.
Yeah? Did you have 8 there instead of 64 times 12? Okay, the good news is that finding the volume of a cone is almost identical to finding the volume of a cylinder. So let's go on to the next page. Next page. Whatever you prefer. I don't write on the back of pages, but that's up to you.
What'd you get?
I didn't hear you.
weeks ago.
I get it pink. I like
My whole cube hole off.
You should try sweet potato.
no. I live myself. You don't want to
Okay, so the formula is similar.
A joke.
Maggie, you're keto?
She's keto. Oh my gosh. She's keto. She's keto.
I accept you.
All right, so the difference here is that we now have this whole 1/3 situation because a cone is a third of a cylinder. If you put 2 cones going like upward and one upside down, they would make a cylinder.
Huh?
I know it seems strange, but a cylinder can be broken into 3 cones. I know it seems strange, but it's actually mathematically accurate. Uh-huh. Right? So it would look like this. So let's say I had a cone here, and then a cone here,
Oh.
and then a cone, right? Like, I know I'm not doing it justice because I don't have it accurate, but it would make a cylinder. Like, this one would have to be a lot. I know it seems like it doesn't work in my drawing, but that's visually what's happening there. Okay? I know, I can't do it justice by drawing it. You need like actual accurate measurements, but it's true. A cone is 1/3 of a cylinder. So the entire process is the same, except our very last step, please listen, is to just divide by 3. So we do the exact same thing we were doing for a cylinder, except at the end you take that number and you hit the division symbol and 3. And that's it. Okay, so let's look at this. We've got volume. We've got area of the base. And we have height again. Because we're talking about a cone, our base is still a circle. So that's going to be the pi r squared again.
What?
Wait, what?
Oh, so.
Not English.
What?
Yeah, so is
Stop.
So again, we need pi, we need the radius value, and the height. I'm only going to do one example for this because it's pretty straightforward. So I'm going to draw the cone. I just start out with like a triangle, and then I put a curved base, and then I have the three-dimensional dashed line back there. So the way to show the height of a cone is to pretend like you're dropping an imaginary line down to the base, and you connect it with the radius or the diameter if that's what you're given. So for this example, the height is 7 centimeters and the radius is 5 centimeters.
Are we going to do approximately exactly?
We sure are. All right, so I'm going to start with my formula. 1/3 area of base times height. One-third pi r squared height. Jillian? One-third of 3.14 times 5 squared times 7. I'm just bringing that 1/3 down each step. I don't do anything with it until the very last step.
Wait, why wouldn't? Oh, never mind. Where'd you get the 1/3?
That's the formula. So to find the volume of a cone, because a cone is 1/3 of a cylinder, we just do the same formula for a cylinder and we take 1/3 of it. Kind of like how the area of a triangle is 1/2 base times height, because a triangle is half of a rectangle. So you do the rectangle and then take half of it. Okay. So we're going to have 1/3 times 3.14 times 25 times 7. Is 549.5 when you multiply the 3.14 times the 25 times 7. And then my last step, 549.5 divided by 3. Right, so like I said at the beginning, you would just put this value in your calculator, hit the division symbol, and 3. And then you have an approximate volume is about 183.17 centimeters cubed. So that dividing by 3 is taking the step of 1/3 of the value. So if this was just a cylinder, 549.5 would be the volume. But because it's a cone, I have to take 1/3 of that. How are we doing? Not terrible, right? Okay, let's move on to the exact value. It's going to look a lot like the approximate. Remember, this is when we leave pi in the answer, so we're not going to write 3.14. So for this one, my last step is going to be to take 175 and divide by 3. Remember, the pi just stays there. The symbol, we just leave it. So you're going to end up with volume equals 58.3 repeating pi centimeters cubed. And I can leave that as an exact because it just has pi. Because I wrote this as 0.3 repeating, I know that that's the exact value.
Wait, why did you do 0.3 repeating?
Because if you do 175 divided by 3, you get 58.33333. And that's just 0.3 repeating. Okay, so if you go to Canvas, there's a couple practices. One is on cylinders, one is on cones. You're going to start that today. It is not homework. And then you'll have more time tomorrow to work on it.
And we finish it tomorrow.
You'll finish it tomorrow. So if you're not here, you know what to work on. Okay.